The next couple of clips you're going to see are extra scenes that effectively didn't make it into the production cut, and the reason being was that we had to keep the time down to around 45 minutes or so. But these are long-range tracking scenes, with the exception of the last one, which is a composite scene you'll see in a few moments. But they all deserve attention because of the significant technical achievement that's involved with capturing these scenes, these images that you're about to see.
Okay, the clip that you're about to see is Echo 207, and this is from Playa Linda Beach Domes. It's about 7.75 miles north of the pad, right along the beach road within the Cape Canaveral National Seashore. Now, this image has been inverted. When it's captured, it's actually captured upside down to the viewer because of the type of lens that's used to capture it. The tracker that's capturing and tracking this image is a dome system. It's a distant object altitude measurement system. This is a very long focal length lens, somewhere on the order of approaching 500 inches in focal length.
Yeah, these are effectively telescopes, right?
Telescope lenses, that is correct. And these are part of the Cape Canaveral Air Force Station, Patrick Air Force Base range safety assets. These trackers are used primarily to ensure the safety of the range. Another distinguishing feature of this image, besides the exceptional optical quality, is the focus is actually driven by range data to keep the image in focus as it passes through the various distances that you'll see here.
Yeah, it's amazing to see the absolute clarity that you get from such a long distance away. Take notice of the body flap. As you can see, it's vibrating. This is right below the Space Shuttle main engines on the back of the orbiter there. And you can see a significant vibration in that. Of course, we knew about that in the design process. We knew that body flap would be undergoing that kind of deformation, but it just sort of hints at the enormous loads that the vehicle is subject to on the way up into space. And actually, if you watch carefully, you can see the vibrational mode of that for the technical people in the viewing audience. You'll actually see the vibrational mode of that change as it goes through a couple of different parts of its flight regime. You see the plume sort of expanding now. If you watch the back of the external tank underneath the engines, you can see it's starting to brown up a little bit. That's because of the exhaust gas recirculation coming out of the boosters, starting to heat up that foam, that insulating foam that's on the bottom of the tank. Nice lighting. These are STS-124 again.
Yes.
So beautiful, beautiful lighting in this evening sun, and you can kind of see it here. And as with all the 124 shots, they were second to none.
And one of the advantages of the focal length that these lenses on these dome systems provides is the capability to look at, in many cases, SRV separation. This clip here is Echo 204, and this is this camera is at Patrick Air Force Base, which is about 31 miles south of the pad, just due south of the pad. Again, this is like Echo 207 is a dome system, so it's a distant object attitude measurement system, and this is a very long focal length lens approaching between 400 and 500 inches. I'm not sure exactly what the focal length is. The image would be inverted, and because of the design of the lenses, it's a telescope lens system.
Yeah, it's really amazing, just like the other one we talked about a few minutes ago. So the solid rocket boosters, as we mentioned in the primary production on this disc, separated about 29 miles in altitude, and you have enormous detail. I mean, you can make out some of the rings on the boosters here. It's just fantastic detail. We're going to see SRB separation in just a few seconds. And the boosters don't actually flame out. They just go to a neutral thrust condition, and once they aren't generating any thrust relative to their mass, they obviously don't have any use anymore for the vehicle, so they jettison them via these little miniature boosters, if you will, called booster separation motors. And that's the big cloud you see as they detonate these. You'll see this big cloud that sort of engulfs the orbiter and the tank, and the boosters are sort of safely moved back away from the orbiter and the tank, so there's no possible conflict or impact. Kind of a nice shot of the plume there. The further they get up into the vacuum of space, you see more expansion of the plume as it comes out of the SSMEs, the Space Shuttle main engines, and the boosters themselves. So we're gearing up for booster separation. There you see it, an enormous cloud of exhaust coming out of those little separation motors. They have 4 of them on the front and back of the booster. And you can see that the boosters actually, as I mentioned, don't go out. They're still burning. There's still quite a bit of fuel on the inside of those boosters. And they will actually flame all the way back down into the Atlantic Ocean. They'll chug. They sort of puff on and off. So they sort of give you the impression they're falling back down to Earth at this point, but they actually have about 15 more miles to go up in the air before they peak and turn around and come back to Earth. And then they're rescued by divers out in the Atlantic Ocean and brought back and recycled for future missions.
This is Echo 217, and this camera is up at Apollo Beach, which is part of the Cape Canaveral National Seashore. And this camera is about 20 miles from the pad when the vehicle lifts off. It's a really an amazing view. The focal length on this camera system is about 360 inches. It's fairly long focal length, and it's using a kineto tracking mount for the tracking system that keeps up with us. So this is manually operated by the tracker operator.
Looks like we're flying through a lot of haze there on this particular day. There's probably some clouds between, long distance, as you mentioned, between the camera operator and the camera itself in the vehicle. And so there's a little bit of haze. You can see that. But still an amazingly clear image. If you look at the bottom of the tank, you can see it's starting to flame on a little bit there, which, as we mentioned in the primary production, that this is a known phenomenon as the hot exhaust out of the boosters and the main engines sort of recirculates back around and touches that tank. And in just a little while longer, we're going to see some booster separation shots.
And in the main video, there was an image from this particular tracking site, but it was a high-definition video using a 150-inch lens. And this is the film companion to that. Right.
There's multiple cameras, up to 4 on one camera operation system that one operator can control. So if you go back and look at keep track of Kevin's call-outs for what camera site we're at, you can correlate that. Great slow motion shot of the booster separating, just like the shot that we saw a moment ago. You see the boosters falling back, safely pushed away from the orbiter and the external tank, and on their way back to Earth. Their total ride is 400 seconds from liftoff to splashdown. It's 400 seconds. They're actually in the water before the vehicle even gets up into orbit.
What you're seeing here is 2 camera views that are actually composited together. Matt will talk about that more in a second. But this is from CS6, 1,200 feet. The camera is from the vehicle. And this is a tracker that's remotely operated by an operator in the launch control complex using a trackball.
Yeah, what we did was we used some software to actually sort of try to track these 2 images together to make them look more aligned with one another, if you will. And it did a pretty good job. And that's why you see that line moving up and down, is that the keyframes that we're trying to hold together there sort of give you an extended view or a panoramic view of the vehicle as captured by these 2 cameras. You can kind of see some of the paper, by the way, coming off there as the vehicle starts accelerating. Those are the paper covers that cover the reaction control motors on the vehicle. Going into the roll program, the software kind of loses the ability to track. You'll see it bounce around a little bit there. But it's actually a very beautiful shot, and the tracking will stop in just a few moments, and the vehicle will fly out of the frame. And I found that to be actually a particularly nice shot. It's not seen too often in tracking. And Kevin, you may want to mention, that this shot really only is concerned with the first part of the launch.
I'm sorry, Matt. The first 18 to 20 seconds is really what this shot is intended to be looking at as the vehicle clears the pad and clears the tower structure at about 300 feet or so.
So this is a nice scene to end our extra features on. We hope you enjoyed it. Hope you enjoyed the commentary, and hope you enjoyed the production overall. Thanks.